Hello, I'm Pam Hoffman, Everyday Space.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 12 noon on Saturday in Hong Kong. We're broadcasting live from Thousand Oaks, California.
And one question for you guys. I've done a couple of cybersecurity episodes. The first one did pretty well. The second one didn't have a lot of people showing up. And so it looks like there's not a lot of interest, in an entire episode of cybersecurity. I mean, this is a space thing. But would you guys be interested in a segment? It wouldn't be every single week, but it'd be when I see something that looks important. Just let us know in the comments if you would like me to just throw something in a segment here, and probably down right around where we do the ephemeris.
Oh, well, we haven't decided where exactly yet, but anyway, anything else?
Nope.
All right, tonight we have a crunchy topic: detoxifying Mars. We'll be back in 8.3 seconds. We have a comment. Let's get to that right away here. Hey, Scott. Yes, cybersecurity updates sound great. And hello, everyone. Hello to you. Yeah. Thanks for being here.
Okay. Yeah. I won't always have something really important to say, but, hey, if you guys are okay with it, I'll gladly spread the word about certain things.
We always enjoy learning. Happy Friday, all spacers. Yeah, it's really great to be able to know kind of what's out there and to protect yourself from different things, which they're getting harder and harder to distinguish from something that seems real.
Well, remember, the number one way to protect yourself from cybersecurity. No clicky. Yep.
All right.
I actually say that to some of my customers.
You do?
Yes.
That's funny. So one of the major hitches in colonizing Mars is the presence of very high concentrations of perchlorates in the Martian regolith, which is also known as soil. How can we get the perchlorates out of the Martian soil? Okay, Jeff, what are perchlorates? Why are they bad? And how can we get them out of the Martian soil? Tell me when you want me to share.
Maybe now, because I'm going to cough.
Okay.
Sorry, folks.
Yeah, asthma weather.
Okay. Well, first off, before I get into all of that, I just want to say that I was inspired by a Fraser Cain video.
Right.
And in fact,
I saw that a week ago.
Yeah. Oops, I just hit it. So
yeah.
Let me get that link to you, because this is very good. I'm not going to cover the same ground that Fraser covered, so it will be good for you guys to watch it on your own.
So this should be a clickable link. It'll show up in the comments for you.
Yeah. So he does a really good talk on perchlorates. I'm going to kind of talk around it. Some of the ideas that came to me from this video. So
okay, good.
So when you have time, go ahead and watch this, because it's also very good. So hey Don.
Hey Don, welcome.
Yeah. So I'll cover some of the stuff that he covered, but not into the detail that he covered it.
It's a very good video.
I mean, this is 55 minutes long. And while I could do that, why? He's already done it, So, so what are perchlorates? It's basically chlorine with 4 oxygens on it.
I do like what you said the other day, though.
Yeah, it's the caltrop of
yeah,
of molecules. And pretty much as fun to deal with too.
Oh, okay.
Because it is highly poisonous.
Yep.
And does not occur through normal chemical processes.
Oh.
The normal chemical processes are just not energetic enough. Like on Earth, almost all of our perchlorates are produced by lightning hitting chlorates, which are basically 3 oxygen atoms on a chlorine, which can be created chemically. But the
And
lightning
where is that? Is it in the dirt? Is it
in water usually,
in the water?
and
Okay.
damp dirt.
Okay.
But
Water based.
yeah, but the lightning produces enough energy to actually slap another, to force another oxygen onto it,
Ah, okay.
and that makes it a very high energy molecule.
Mm.
And you get one of those bouncing around in your cells, and it, for one thing, oxygen is why our cells develop cell walls. This to protect the innards of the cell from oxygen that's not being bound to something. Well, perchlorates don't mind giving up an oxygen.
Makes sense.
Or 2.
Because they were kind of forced to take one on.
And so what it does is it essentially burns your cells from the inside.
Oh, far out.
So it is not good stuff. Even in low concentrations, it's poisonous. And the Martian regolith is not low concentrations.
Okay.
In fact, because it's not created through normal chemical processes, and Fraser hits on it too, is that the thought is that the perchlorates that were concentrated by the evaporation of their oceans spent millions of years getting hit by cosmic rays, and that the energy of the cosmic rays hitting specific atoms was enough to basically give the energy to grab that other oxygen.
Let's reel back a little bit, because it sounded like when you said the oceans dried up on Mars, there were perchlorates. I think it was
no, there
chlorates,
were chlorates. Yeah.
Okay. Yeah.
Yeah. There were.
So we had this 3 oxygen
and
1 chlorine.
Yeah. In fact, let me
thing.
go down and
you want me to show you?
Yeah. Here we go. These are different. These are perchlorates. What we're talking about: chlorates, chlorite, and the main thing is, if you notice, 4 oxygens, 3 oxygens, bunch of stuff. 2 oxygens with a hydrogen on there, and then 1 oxygen. So these are the chlorite groups, and perchlorate has the maximum number of oxygens that it can actually hold.
Okay.
And it's also the highest energy. In fact, in order to break it down, you have to give it 14 electrons, which means that it's not really easy to break down in a normal chemical plant.
Okay.
Because for one thing, you have to get those electrons from somewhere, and so you end up with something else that's just as poisonous once you've grabbed those electrons from it.
Oh.
Not, so
hey.
there aren't good solutions. This is a solution. I mean, aside from whatever gave up those electrons, you get chlorine gas, which is not great, and 8 water molecules. So that's a okay solution as long as you have somewhere to put that chlorine gas.
Okay.
Because you don't want to snort that stuff.
No.
You don't tend to do that more than once. But so.
And that's the stuff you get when you do bleach.
You're right.
And ammonia.
Right.
Which a lot of people think would make a really good cleaning solution, because bleach, ammonia, mix them together. No.
Well, the next people to own that house will find it very clean.
You'll be in trouble, because it creates poisonous gas.
Your heirs will find it very clean.
I see. Hey, Cliff, thanks for joining us.
Yeah.
Yay. Glad you're here.
Yeah. So, another way that you could do it is you can literally just wash it out. But that takes water. Lots of water.
Mars,
it's kind of a precious thing. And so you're trading poisonous soil for poisonous water.
Yeah, it's pretty precious here too. I mean.
Right, but it's easier to come by. But
Then
you
on
know,
Mars.
right? Yeah. So
Yeah.
having poisonous water is not a step up from having poisonous
No.
soil. So that's not good. Yeah. In fact, you can't even really grow plants in this
Oh,
because plants will grow in it. The trouble is that they take up the perchlorates. So I'm sorry, but in that Martian movie, he'd be dead because those potatoes would be poisonous.
yes.
So,
Well, it's science fiction. We know that, and
right.
it's possibly a different galaxy.
And they also had a sandstorm blowing stuff over. No. I mean,
Not with that atmosphere.
yeah, not with that atmospheric pressure.
It makes for an exciting story, though.
Yeah.
Yay. All right, so let's see. We decided what they are.
Yeah.
And why they're bad. I think we
yeah.
know why they're bad, right?
Yeah. And
it just releases its oxygen, and
yeah.
You were telling me before. What is it? What did you say? Burns right through you? Ugh.
Yeah. It essentially burns because it's an oxidizer. Now that makes it really good for rocket fuel.
Yes, and that is used for rocket fuel out there. Dawn says, so trying to free the oxygen for other uses seems unlikely.
No, actually, Dawn, it's not unlikely because there's another way of getting rid of it. And Fraser talks about it in his video. So I looked it up.
Oh, wait. You ready?
Yeah.
I will share then.
Okay. Detoxifying Mars, the biocatalytic elimination of hominid. Basically, there are some microbes that not only can survive the perchlorates, but survive off of them.
Oh, they basically eat it. Okay.
Because there are some critters that, if there's no oxygen present, will actually use the perchlorates to produce the oxygen. Since the perchlorates want to give off the oxygen, they've developed the chemistry to pull the oxygen off of it.
Okay.
Without like killing themselves.
Huh.
And and in this image here,
wait. There it is.
These critters can take the water because they need to live in water. But you put the perchlorates and chlorates in that water, and they'll live off of it. Give you water, chlorine, and O2.
That sounds a little more useful.
Yeah, I mean, you've got oxygen, you've got chlorine, which can, in low concentrations, keep algae from growing in the water. Which you might think, well, we're going to be bringing water to Mars, or we're going to be bringing equipment to Mars, and so we won't have algae. No, algae spores are everywhere, on your skin, the chance of getting rid of all algae spores on the way to before you send someone to Mars, not good.
So Scott says, just turn half of Mars into a bioreactor and we will be good. Yeah, I got the turn.
Yeah.
Thanks.
Yeah. It does need, better conditions than the surface of Mars. So we can't just throw this stuff out there. But one of the things
in the image, it does say bioreactor. So.
Right. Yeah, but they mean like a vat, like you're brewing beer.
Yeah. Okay. That's kind of what I was thinking when they. Okay, but.
Yeah. So what do you do with that chlorine? Well, like I said, you can chlorinate the water. That's good. But you could also, if you find a source of sodium, make salt, which we need. Not in high concentrations, but we need it.
Sodium chloride, right?
Yeah. Now, I also did a little bit of looking for what are sources of sodium on Mars. And now no one's really been looking for it, I think.
Okay.
But I found some things of composition of Mars and mineralogy of Mars.
You ready?
Sure.
Okay.
So here's composition of Mars on a wiki. Mineralogy of Mars. And there are some minerals that have sodium in there, good old Na. But not a lot. Feldspar is the probably most likely source of it. But it's all fairly well bound up in rocks, which we could probably free it from those, but
Okay.
but it
Scott has
doesn't.
another comment.
Okay,
You ready?
sure.
I am sure the bacteria need more warmth at the very least.
Mm-hmm.
Got it.
And higher pressures than Mars gives you,
Oh,
but because they need to be in water. You know, any water that you put on Mars will either freeze or vaporize from the low pressure.
well, but if you got them in a vat and
Yeah,
give them the right environment and
yeah,
let them eat the stuff and
yeah,
reproduce.
yeah. And Fraser went into it a little bit in more detail, but apparently the bacteria that we have now for that currently live off of that can live off of perchlorates will also live off of oxygen preferentially. So if there's oxygen present, they turn off the perchlorate eating because that's less efficient. So, but
if they're producing it, most likely turn on eat that too, unless you
right, yeah,
pull it off, right?
Right.
Okay.
But one of the things that they're talking about is genetically modifying them so that they basically remove that switch.
And Cliff has a comment. And what if there is a very harmful bug we don't know? We don't want to bring that back to Earth.
Yeah.
Absolutely.
Yeah. Now, one of the good pieces of news from this, and they don't talk about it in the video, but I've just basically put things together from it. Since perchlorates don't normally occur and weren't really created in large amounts until like a million years after everything dried out, there aren't likely to be any perchlorate eating critters.
You mean on Mars?
On Mars. So, so we don't have to worry about that. Now, there are likely, if there's anything sporified on Mars, waiting for some liquid water to wake up, it's likely to be a very high salt. And by salt, we don't mean sodium chloride, mostly potassium chlorides.
Yeah, anything with the ID on them, it's a salt.
Yeah, but probably whatever critters are there, if there are any, evolved to live in high salt concentrations.
Okay.
Just because the oceans evaporated and probably did not go fast. Yeah, did not go fast. So anything that would have survived would have learned how to live in that.
Okay.
So, let's see.
Should I share again?
Oh, yeah. I just wanted to.
Is that a yes?
Yeah.
All right.
Okay. Yeah. Go. This article, it's a really good article. It's
a website for
phase
one.
This website is explored NASA.gov.
Okay, NASA.gov.
In their general category, detoxifying Mars. But it comes from a list, basically a grant. This is a phase 1 grant. And, it's right here. And this goes to that article. But this is the NIAC 2024 selections.
That's you just
NIAC.
Yeah. Okay.
Yeah. So there's some interesting articles in here just for other things. So I think I'm going to share this because you can get to her article from it. You can also get to a whole bunch of other really interesting articles.
So while you're doing that, Cliff goes, but you never know with bacteria.
Right. And you never know that whatever bacteria there is can actually survive on the chemicals that we use to live on.
Okay.
Because there's so many variations on just the types of sugars out there. They can be built in a lot of different ways, and shapes of molecules, when you're talking biology, matter.
Okay.
So even the same molecule with a different shape may or may not be compatible with Earth biology. Like you've heard the term left-handed sugars. We can't really digest them because they're shaped wrong. Now, they also aren't really good for you in other respects. So using them as a diet fad was kind of short lived. Um, Apparently, your body still thinks it's sugar, and so if your body will dump a bunch of insulin, and the insulin won't have anything to do.
Right, it won't have anything to eat.
Right, won't have anything to store. So that can be bad.
Yeah.
So, but there are but aside from a flip of the cosmic coin, we could have developed using that quote left-handed sugar, which we wouldn't call left-handed sugar. But so 50-50 chance that even if they used sugars, they used the wrong kind of sugar to interact with us. So, that's the, I'm not as concerned about contamination.
Like now, from Mars to Earth?
Or vice versa, of us contaminating other critters.
Okay.
Now.
Well, but we may have already been seeded by certain things that come from Mars, but I've seen articles about it, but who knows how likely or unlikely that is.
Right. Well, because this thing, Mars, because it looks older, because it's dead, isn't older than the Earth.
No.
So they developed about the same time. The chances of
I think most Mars, of the things in the solar system did, right?
Right, yeah. So the chance of Mars having life before Earth, not likely. At the same time as Earth, probably. But then the whole,
and now who knows?
We get pieces of Mars blown off when an asteroid hits Mars. And that's where our Martian meteorites come from.
Yeah.
But at the time when stuff was alive, there would have been an atmosphere. Stuff wouldn't have gotten blown off quite as readily as they can now. So would we have gotten any of those meteorites from Mars when that had liquid water? Yeah, don't know. So
much to learn still, huh?
Yeah. Now they have found the building blocks of life in the asteroids, and basically, heck, in gas clouds, in the dust clouds, interstellar medium.
Oh.
So could we have hit one of those and it seeded us with the building blocks? Sure. But it's like Legos. You can build so many different things with it that we just happen to build the stuff that makes our life.
Is it life, though?
Right, yeah. And and I think we covered it in a previous episode, the chance of finding multicellular life isn't high because it was, a specific mutation that led us to be able to do it.
Yeah, that was the eukaryotes.
Yeah.
Talk, yeah.
Cool. And so, now could we find slime molds? Sure. Could we find slime molds that maybe they can't eat us, but maybe they can grow everywhere and produce chemicals that aren't really good for us? Sure. We have molds right now that produce spores that aren't good for you. And, and it could be as simple as an allergic reaction. They might not even be growing in you, but if it's an allergic reaction, anaphylactic shock.
Yeah, apparently they haven't really been able to overcome the temperature of our bodies, but they're evolving. So,
but
some good stuff about that out there.
So alien critters would be interesting. You'd still wouldn't want to slurp them up out of whatever soup they're in, but probably But chances of finding things with legs, I like to use in my head about 1 in 100 of life-bearing planets would have multicellular. I have no basis for that.
Well, there is
it's
something
just my own head.
There's something called the Drake equation. You can plug in all kinds of, theoretical numbers, and since they're multiplied, you would get some kind of. And I saw a graphic once of the potential for. I think you actually put the numbers in, and it would go in the whole universe. This would be civilizations that would grow, rise, and fall, and it was really cool. Like had little rings of. Anyway, it was neat.
Yeah.
The Drake equation is a very interesting theoretical concept for what's possible out there for life. Maybe.
Yep.
Lots of maybes in there.
Yep.
Do you have anything else for us?
Not really. I mean,
I thought I saw another tab.
Well, this is something talking about chlorine, because what do you do with the chlorine? Chlorine will break down in sunlight.
Okay.
I mean,
and there is some sunlight on Mars.
Yeah.
Sure.
I had a pool as a kid, so I know this one. You have to keep adding more chlorine.
Yeah.
So the chlorine that's produced by the bioreactor isn't terrible, even if you can't use it all.
Okay.
But in low doses, it does keep stuff from growing in the water. So, in fact, the tap water that we have has chlorine in it. Not a lot.
No.
And we don't even really notice it.
No.
In fact, you can't even really taste it at those concentrations. But a lot of the, tablets that they sell, survival tablets for putting in water, high doses of chlorine.
Yeah.
And
there's a specific
you can really
way
taste it.
to.
Yeah. You can really taste it there, because it's speed versus, they want high concentration so that you can have water to drink in minutes instead of hours. So.
Yeah, it does take some time and letting it rest and so forth. So.
Right. Yeah.
If you get a package of it, it'll have instructions on how to make that work. So yeah.
Right, and just normal chlorine at low doses, sure, but it takes flipping forever for it to work. And it's more to prevent things from growing than to kill things that are already there.
I know sunlight can do some things for water.
Right. Yeah.
Okay.
Yeah.
Yeah. What does chlorine break down into?
It more combines with things.
Okay.
And combines with hydrogen. Combines with it combines with a lot of things. And potassium.
Okay.
No, it takes the same role as potassium, so they're equivalent.
Oh, interesting. Cliff says on the Drake equation, it's been updated a little bit, and there are more possibilities. I did not know that. Thank you very much for it. And Scott says, I wonder how nutritious those bacteria would be as people food.
Oh, you mean for the bioreactor bacteria? Given that they're steeped in perchlorates,
probably not.
Yeah, more for you, Scott.
No. Don't try that.
Yeah, I don't see that as a good idea.
Well, a lot of things do get processed, like tapioca. It comes from the root. A tapioca seed.
Right, yeah.
Comes from the root. That's poisonous, but it gets processed. Scott says, yum. Thanks for playing.
Yeah. Now, probably if you can get it to kill, to get rid of almost all of the perchlorates, yeah, you could probably eat it and not have it not be too poisonous. But because
doesn't sound very appetizing, though. Because let's have some bacteria from the bioreactor.
Yeah, because I can't imagine
eat up the perchlorates.
Yeah. Woo! Yeah, I can't imagine any biological system being 100% effective. I just don't see it as getting rid of all of them before they all die from lack of food, essentially.
Okay.
Yeah. So, yeah. It's kind of like, hey, you can drink battery acid when the battery's dead. You could. Wouldn't recommend it.
Okay.
So,
are you two done?
Sure.
We like our audience. Let's be nice to them, huh?
Well, the good news is, in the perchlorates, let me just find this.
Wait, you sharing something else?
Not necessarily. Terrestrial abundance on Earth. It's estimated to be 100,000 to 3 million tons of perchlorates on the entire Earth.
Got it.
So that's not a lot. So your chance of finding it on Earth are not, you know,
But they do make it for rocket fuel.
yeah. Apparently, there's some
know that one.
in a desert in northern Chile.
Oh.
Um.
He's weighing in on this one.
Mm-hmm.
Silly rabbit.
Yeah. So you're not likely to find it. So that's
Did they say
good
how
for
much
Earth.
on Mars, like by comparison? Detect on Mars soil. There it is, about 0.6% by weight.
Yeah.
Wow.
Yeah. So that's a high concentration. That's not parts per million. That's parts per 10. You know, or parts per 1,000. Yeah, because that's a percentage.
0.6%. Yeah.
Yeah, out of like 100. 100. Yeah. So it's about
6 pounds of the 100 that's perchlorate.
Out of every 100 pounds, you'd have half a pound essentially out of every 100 pounds. So every 200 pounds
a lot more
of dirt would give you a pound of perchlorates, which
Yay.
is really high concentrations. I mean, much higher than you'd find on Earth.
If we can harvest it, though, we can use it to power rockets. I know someone who had a barrel of this stuff in his backyard.
Yeah.
And I think it's a singular because of all the oxygen, right? It's a singular, not, well,
no,
let's see. It had to be combined with something in
aluminum.
Once they were combined, once it was combined, it would ignite.
Right. Usually they
it's a biofuel.
They put put aluminum with it because the aluminum will take up the oxygen. Now, if just sitting there dry won't do anything. You need to do something to shock it to start it going.
You're talking about the perchlorate
with aluminum, yeah.
Oh, I see.
So you need some kind of electrical or other kind of shock to get it to start going, but then the heat of it will continue the process.
Oh yeah, it's a chain reaction. That might be a good show. Talk about different fuels and
rocket fuels.
Yeah. I don't think we've done that.
Yeah.
There's some interesting stuff out there, and I know some of the people make it. All right.
We all know some people who make it. Some of them do it officially.
Yeah,
and
these guys
most of them still have all their fingers.
Yeah, these guys do. Alrighty, anything else from you on that?
No.
And we'll continue to watch for your comments, of course, because I can go into the stellar events for this week, and it's going to be a busy week. My goodness. We're talking about June 28th through July 5th. There's pretty much something every single day or night this week. The current Globe at Night project continues. For example, this is going through July 5th, and you can look for Hercules in the northern hemisphere, Scorpius in the southern hemisphere. And this is a really great way to do citizen science and make a really, really important contribution. Apparently, this is a really important project, so they can understand what the heck is going on in the world involving light pollution. You go outside, you take a look, you can either report on your mobile device or you can report on the website what it is you're seeing. They talk about cloud cover, all kinds of stuff. June 28th is tonight's also the last quarter moon, and it's on the moon is on the equator. Also, Mercury is at 4.7 degrees south of Pollux, and Neptune and the moon are in conjunction. June 29th, the moon is at ascending node. June 30th, Saturn is, or appears to be, stationary. July 1st, Mars and the moon are in conjunction. Mars is, in fact, 4.1 degrees south of the moon, and it's Canada Day. Cool, huh? July 2nd is Uranus and the moon are in conjunction, and Neptune appears stationary. The Pleiades.
Now I've got you doing it.
Yeah, well, it's true. The Pleiades is 0.3 degrees north of the moon, and I guess there's an occultation visible from somewhere. We didn't see the note on where, but
yeah, they didn't list where, but I'm going to assume that since the source is a U.S. source, North America.
Probably somewhere in North America. Oh, we got a comment, so let me mark this and we'll get back to that in a second. Cliff says aluminum perchlorate is the fuel of the boosters of the space shuttle and many more.
Yeah.
Aluminum perchlorate. Okay.
Yeah.
Cool.
Yeah, because aluminum burns good if you give it enough fuel. or enough oxygen and enough heat to actually start the process.
Okay. All right. So July 3rd, Jupiter and the moon are in conjunction. In fact, Jupiter is 5 degrees south of the moon. July 4th is our Independence Day here in the United States, and the moon rides high. July 5th is the new moon.
Good thing the moon rides high, because it's going to be a lot of low-level fireworks going on.
Okay. July 5th is the new moon, and Earth is at aphelion. That's the farthest away, right? Apex. Yeah. Farthest away from the sun. So in its orbit, the Earth will come a little closer and a little farther away at certain times of the year. And on July 5th, it will be at aphelion, the farthest from the sun it gets. Right. July 5th is also...
That also shows you that the angle of the Earth has much more effect on our temperatures than the distance from the sun.
Right.
Because it's quite warm, but we're also the farthest away. Yeah. Now, when you get really hot temperatures, it's when we're at the closest in the summer. Because that changes the distance from Earth to the sun, changes per year. So
it's changing every day.
Right, but no, I meant the
talking about aphelion or perihelion.
Yeah, those two change every year. They hit on a different day.
A little.
Yeah,
okay,
not a little bit. They kind of move themselves through the year.
Oh, I see.
Over the decades, they'll move themselves through the year, which is why some decade, some years are going to be much hotter than others, and it all depends.
That'd make an interesting chart, wouldn't it?
Yeah.
Okay.
I've seen one. I don't remember where, but I've seen one.
Okay. July 5th is also our Friday night show, and because it's the day after Independence Day, I think we're gonna come, but we'll talk about what we're gonna do. Oh, Cliff says once you've lit that candle, it will not stop. Yes, yep. I can totally
until it runs out. Yeah, that's why the solid rocket boosters, which are not throttleable, were used on
them.
Yeah, I mean, the only way to stop them was to basically break them loose from the vehicle and let them fly off, and that's what they did. They usually ran them out, but
I was gonna say they weren't burnt out by then.
Well, they would usually leave with a little left so that they could actually separate out from the vehicle.
Got it. Okay.
But yeah, if you decided that you needed to abort, yeah, you just cut them loose and hope they move away from you.
So on the Friday, the July 5th is Friday. We're going to be here. We are going to, I'll talk about that in a minute, but find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. What inspires you the most for this coming week?
Okay. If you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, July 5th, and we'll be celebrating Independence Day. So we'll stop by and chit chat for a while and, find something interesting happening out there.
There'll be something interesting.
Yeah.
And I haven't really shared a whole bunch of these kind of events. I did find some today. I'm like, oh, that'd be a good thing for next week. And I think I had something else in mind. Mm-hmm. But it's marinating.
Yeah.
All right. So anything else from you?
Nope. Yeah, we plan on double dipping on the fireworks because there's a place doing them on the 3rd. And so, and our place doing them on the 4th. So double dip.
Yep. Looking forward to that. Apparently it's cheaper to do them on the 3rd. I did not know that.
Yep.
So, don't forget your shout out. Yes. So thanks, Cliff, for being here, and Janie, and Scott, and Dawn.
I think that's all who commented.
Our regulars.
Yep.
Too bad we don't serve coffee. All right, folks, you make this much more interesting than it normally might be, and we really appreciate you being here. Mm-hmm. So, have a great week, and check back next week. We'll kind of chit-chat, and maybe we'll have a couple of other things in there. I don't know. We'll see what happens.
Yeah, if something interesting happens in the cybersecurity world.
Yep, we'll definitely tell you that.
Yeah.
Nope, we got one more.
One more comment.
One more. Oh, did you find whoops.
Oh.
What happened?
Hey, Drew.
Oh, someone you know? Because I had...
Yeah.
I thought we had... Okay, we got a bunch of them here.
Yeah.
We got... So, Janie's is...
Yeah.
Thank you as well.
Yep. And
Well, yeah,
okay.
it's true.
Yeah. Hey, Drew.
All right. So shout out to Drew as well
yeah.
then. Thanks for joining us.
Yep. So, oh,
Oh, no kidding.
nice.
How cool is that?
Yep.
All right.
Well,
We will. Oops.
more
Aw,
Drew.
that's nice. We like that.
Yep.
Cool. We'll
Okay.
continue to watch for your comments, of course. And
Yeah. Drew, every Friday at 9 p.m.
Yep.
And I don't know if you caught the beginning of the show, but you might want to look back on it if you missed it, because and people are fairly lively in their comment.
Oh, thank you, Dawn.
Yep.
Really appreciate that.
Yep.
All right.
Okay.
So we'll continue to watch for your comments. Have a great holiday weekend for our friends in the United States. I know it's going to be Independence Day between. Oh, Drew just got home from work. He says.
Okay. Yep.
Got it.
So, yeah. So yeah, if you're interested in detoxifying Mars, start off and then look in the beginning of our comments for the link to a really, really good video that goes into a lot of detail on it.
Yeah, great video.
Yep.
And he's been in this a long time.
Fraser Kane, yeah.
Yeah, Fraser. Okay, folks, have a great week.
Yep.
We'll see you
Good
on
night.
Friday the 5th. Bye.
Bye.